This is a walkthrough of problem 3 on exam 1 of module 7 in the book Problem Solving Guide for Mechanics and Thermodynamics. We have an 18-foot ladder that makes an angle of 60 degrees with the ground. At its base, the wall upon which it rests can be considered frictionless. The ladder has a mass of 15 kilograms. A 50-kilogram person climbs 2/3 of the way up the ladder. What is the magnitude of the force the wall exerts on the ladder? And part B, what is the magnitude of the frictional force the ground exerts on the ladder? Okay, we're going to use a good diagram. There's the ladder, there's the wall, there's the ground, the angle of 60 degrees. Let's put a person on the ladder, 2/3 of the way up. What are the forces on the ladder? Let's be careful. The ladder itself has a mass of 15 kilograms, which means gravity is pulling on it with a force of 150 newtons. The weight of the ladder. The woman on the ladder has a mass of 50 kilograms, which means she's pushing down on the ladder with a force of 500 newtons. These are the forces on the ladder. We also have the normal force from the ground, the frictional force from the ground, and the force from the wall. The wall is frictionless, so it can only push directly out, perpendicular. Those are the forces. Part A asks for the force on the ladder from the wall. Let's take torques about the point where the ladder contacts the ground. If we do it here, then we eliminate Fn and Fr from the equation. They're zero distance away. And the two knowns, F gravity, 150 newtons, F woman, 500 newtons, are included in the equation. So we're going to only have one unknown. The clockwise torque is from these two forces. The counterclockwise torque is this way. Tick, 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 around the red dot. So we're going to draw only the components that produce a torque about the point of rotation. What are the components that produce a torque? First of all, Fn and Fr are eliminated. See you later. Let's get rid of those. Now let's think about F wall. It's 18 feet away. The ladder's 18 feet, but it's not perpendicular to the distance. We want this component, the perpendicular component. The force, the angle this force makes with the ladder is 60 degrees, and we want the opposite side. We want this side, which is sine 60. So F wall sine 60 should be right about here, the perpendicular component of this guy. F wall sine 60, let's put it on the diagram. Let's get rid of that. And there's F wall sine 60. It's shorter than F wall, right? There's F wall. It's about 86.6% because that's the sine of 60. There it is. That's one of the forces. Now let's do the same thing to the forces that are producing the clockwise torque. F woman is down this way. The perpendicular component should be we're going to go away from the ladder until we reach this tip of this somewhere in here. So that's the opposite side. This length right here, we want the opposite side of 30 degrees. So if this is 60, that's 30. We want that side. Should be right about here. There it is. The component of gravity that's rotating it is the same thing. That's 30 degrees. We want the opposite side. So sine 30 should be about right there. There it is. Okay, so now we can see these are the three forces that are rotating the ladder, clockwise, clockwise, counterclockwise. The torques have to be equal, which obviously this is not to scale because it looks like this guy is going to win. It's a big force. The clockwise torque about the base of the ladder, clockwise, are from these two forces. The ladder is 18 feet. The center of gravity is 9 feet away, and there's the force, F gravity sine 30. A woman is 2/3 of the way up the ladder. That's 12 feet. 2/3 of 18 is 12, and the force that's perpendicular is F woman sine 30. Substituting in for the magnitude of the forces, we get this, and we can push the buttons on the calculator, and we get 3675 newtons feet for the clockwise torque. The counterclockwise torque is only from the wall. It's 18 feet away, and the force is F wall sine 60. So we can set the torques equal. F wall sine 60 times 18 feet is the clockwise torque, 3675 newtons feet, and we can solve for F wall, and we get 240 newtons. There it is. Part B asks for the magnitude of the frictional force on the ground that the ground exerts on the ladder. So let's go back to the original force diagram, and we can stare at it and think, do you want to take torques about the point where the ladder contacts the wall? Do you want to take torques about the center of gravity? What do you want to do? Or you can just stare at it and think. Think. What is it? Look at it. Do you see it? There's only two forces in the horizontal direction, F wall and frictional force. They have to balance. It's got to be 240. The wall is not accelerating in the x direction. The forces must balance in the x direction. That's problem 3.